Welcome to my channel. Today we'll start graph theory, which has a very wide range of application in computer science, networking, etc. Many physical problems can be represented by graphs. So in this video, we'll define graph and we'll discuss the basic terminologies required to understand graph theory. So let us go to the definition first. It says a graph G is a pair of sets V and E, where V is the set of all vertices and E is set of two element subsets of V called edges. Now, how to represent graph? So to represent vertices, we use dots, and we represent edges by lines or curves joining the vertices. For example, this is a graph where we have the set of all vertices as A, B, C, D, E. These are the vertices, and the set of all edges, say E1, E2, E3 and E4. So here we have four edges. The name of the edges are say E1, E2, E3 and E4. So here we can also write this as it is AB, E1 is AB, E2 is BD or DB, E3 is CD or DC. These are not ordered pair of elements. They are unordered pair of elements. It may be AB or BA. We can write anything. CD and DE or ED. So this is the set of all edges. Now we also represent the graph by GPQ if P represents the number of vertices present in the graph and Q represents the number of edges of the graph. So either we represent the graph by GVE, the set of all vertices and set of all edges, or we can write this as GPQ, where P equal to the number of vertices and Q equal to the number of edges. Now, this P is called, that is the number of vertices is called the order of the graph, and the number of edges is called the size of the graph. Next, the terminologies. We use the term incident whenever an edge is incident with the vertices. That means we say E1 is incident with V1 and V2. So an edge is incident with the vertices it joins. So an edge is incident with the vertices it joins. So for example, for G1, we can say E1 is incident with V1 and V2. E2 is incident with V1 and V4. E2 is incident with V1 and V4. Next, the term adjacent. We say two vertices are adjacent or neighbor if the vertices are connected by an edge. Like E1 connects V1 and V2. So we can say V1 and V2, these two vertices are adjacent. So any pair of vertices that are connected by an edge are adjacent. For example, V3, V4 are adjacent. Or neighbors. V3, V6 are adjacent. But V1, V5 are not adjacent. Next, what is called isolated vertex. If a vertex is not adjacent to any other vertex or it is not incident with any other edges, then we say this is isolated vertex. So here we have in the graph G1, we have V5 as isolated vertex. And what is called pendant vertex? If a vertex is incident with only one edge, then we say it is a pendant vertex. If a vertex is incident with only one edge, then the vertex is pendant. Here we have a pendant vertex which is V6. V6 is a pendant vertex. Now we can classify graph depending on the nature of edge present in the graph. So here we may have two kinds of edges. One is called directed edge, the other one is called undirected edge. For example, if you consider the graph G2, here the edge E1 is associated with unordered pair of vertices. That means E1 can be written as V1, V2, or we can write this as V2, V1. So this is not ordered. And if the graph contains the edges, all the edges belonging to a graph are associated with unordered pair of vertices, then we say the graph as undirected graph. So if each edge is associated with unordered pair of vertices, then we say a graph to be undirected graph, for example, G2. Secondly, what is called directed edge? If an edge is associated with an ordered pair of vertices, like in G3, our E1 is AB. So there is a direction from A to B, not from B to A. So this is the edge along which we can go from A to B. We cannot traverse from B to A along this edge E1. So this is an ordered pair of vertices E1. And here we can see each of the edge in G3 is associated with an ordered pair of vertices. So if in a graph all the edges are directed edges, that means associated with ordered pair of vertices, then we say this is a directed graph or digraph. So if each edge in a graph associated with ordered pair of vertices, then we say it is a digraph. So here E1 is associated with AB. Then if we write E5, then E5 can be written as, so there is an arrow from D to A, so it is GA. Similarly, we can write E3 as BC, E2 as BC, and E4 as D2C. Next, what is called self loop in a graph? If an edge connects a vertex to itself, then it is called a self loop. For example, in the graph G4, we have E1 as a self loop, since E1 connects the vertex A to itself. Next, parallel edges. If there are two or more edges present in a graph that connect the same pair of vertices, then we say these are the parallel edges. For example, in G4 we have E4 and E5 as parallel edges. Since E4 and E5 connect the same pair of vertices C and D. Now, depending on the presence of self-loop and parallel edges, we can classify graph as simple graph, multi-graph, and pseudo-graph. Now, if in a graph there is no self-loop and parallel edges present, then we say the graph to be a simple graph. For example, this is a simple graph, say G5. But G4 is not a simple graph because there are parallel edges and self-loop present in the graph. So if there is no self-loop and parallel edges, then we say this to be a simple graph. If in a graph there is parallel edges present, graph with parallel edges, is called a multi-graph. For example, this is a multi-graph. Now, what is called a pseudograph? A graph that contains both self-loop and parallel edges. G4 is an example of pseudograph. G4 is a pseudograph. Next, we'll talk about walk, trail, and path. A walk in a graph G is a finite sequence of vertices and edges such that each edge EI in the sequence joins VI minus 1 and VI for I equal to 1 to n. And this is called a V1 to Vn walk. V1 and Vn are called the terminal vertices. And all the other vertices, that means V2 to Vn minus 1, are called the internal vertices. Now, a walk from V1 to Vn is called a closed walk if the terminal vertices are same, V1 equal to Vn, and it is called open walk if V1 is not equal to Vn. Now let us try to construct a walk from this graph, say G5. So this is just a walk. So this is just a sequence of vertices and edges. So let us first try to write a walk W1, which is a walk from say V1 to V3. So we can select V1, E1, V2. Then we can go in this direction. So V2, then E3, V3, then E2, V2. From here we can go in this direction. E7, we can traverse along E7, E7, V5, then E4, and we can get back to V3. So this is a possible walk from V1 to V3. So here we can see we can repeat both edges and vertices because there is no such restrictions about occurrence of edges and vertices more than once in a walk, because this is just a sequence of vertices and edges. Let us try to write another walk in G5, say from V1 to V7. So we can construct this walk as V1, E1, V2, E7, V5, then E8, V6, and E10, V7. Now we can also represent this walk by just mentioning the names of the vertices V1, V2, V5, V6, and V10, V7. Here we can see between V1 and V2 there is only one possible edge. Between V2, V5 there is only E7. V5, V6 we have only E8 and so on. Between V6 and V7 we have E10. So whenever we have only one edge present between two vertices, we can keep writing the name of the edges. But whenever we have parallel edges present, so in that case, we must write the name of the edge that we are selecting for the walk. Next, let us go to the definition of trail. What is called a trail? If in a walk, no edge is repeated, then we say this to be a trail. And if in the walk no vertex is repeated, then we say this to be a path. So in a walk, if all the edges are distinct edges, then we say this to be a trail. And if in a walk, if all the vertices are distinct vertices, then we say this to be a path. So whenever we use the terms trail and path, we have to be to some extent careful. Now a closed trail is called a circuit. Circuit is a closed trail. That means in a trail, if the initial and terminal vertices are same, then it is a circuit. And a closed path is called a cycle. Now let us try to write some trail and path from the graph G6 say. So first let us write W3, a walk from V1 to V4 say. So if we write V1 to V3 via E2, then V3 to V1 via E3, then E1, V2, E7, and V4. So this is a walk from V1 to V4. Here we can see V1 is repeated. The vertices are repeated, but all the edges are distinct edges. We have E2, E3, E1, and E7. So W3 is a trail. And this is not a circuit because this is a trail, but this is open trail where V1 is not equal to V4. The initial and terminal vertices are not same, so this is just a trail. Let us try to write another walk, say W4. It is from V1, E1, V2, E7, V4. So here all the vertices are distinct vertices, so this is an example of path. Now, if we write W5 from V1, E1, V2, E7, E4, then E4, E3, V3 to V1 by E3. So this is an example of cycle because all the vertices are distinct vertices except the initial and terminal vertices. So here we have another observation from W3 and W4. If no vertex is repeated, then no edge is repeated. So here we can conclude that every trail is not a path, but if we have a path, it has to be a trail. So every path is a trail, but every trail is not a path. Next, what is called connected graph. A graph G is said to be connected if there is some path from any vertex to any other vertex. Say if we have this graph, so this is a connected graph because if you select any pair of vertices, say AC, there is a path from A to C along E1 and E2. So this is an example of connected graph. But if you consider this graph, so if we select the pair of vertices as A and C, between A and C there is no possible path. Between A to C, if we want to write a path, a walk, then A and C are not connected. So this is an example of disconnected graph. So between A and C there is no possible path. So this is a disconnected graph. So this is say G7 and G8. So G7 is connected graph and G8 is a disconnected graph. So if between every pair of vertices there is a possible path, then we say the graph to be connected. If there is no possible path between every possible pair of vertices, then this is said to be a disconnected graph. Thanks for watching. If you enjoyed the video, then please like and subscribe my channel.